The Eiffel Tower, a symbol of Paris, holds a secret. It grows taller in the summer. This isn't magic, it's science. The reason? Thermal expansion. As temperatures rise, the iron structure of the Eiffel Tower expands, just like most materials do when they get warmer. This fascinating phenomenon isn't unique to the Eiffel Tower. It affects structures and objects all around us. Imagine molecules as tiny balls, constantly jiggling and bouncing around energetically. Heat is like giving these molecules more energy to move. As they heat up, they jiggle faster and spread further apart. This increased movement and spacing makes the entire material expand. When the material cools down, the molecules lose energy and move closer together, causing the material to contract. Metals, like the iron used to build the Eiffel Tower, are particularly susceptible to thermal expansion. When temperatures rise, the metal structures expand, and when temperatures drop, they contract. This phenomenon is due to the nature of metal atoms and their arrangement. Their atoms are arranged in a way that allows for greater expansion compared to other materials. When heated, the atoms vibrate more vigorously, causing the metal to expand. This is why you might notice gaps in metal bridges or railway tracks. They are designed to accommodate this expansion and prevent structural damage. Think of a metal spoon left in a hot cup of tea. The heat from the tea causes the metal molecules to vibrate faster, transferring that energy to your hand. This is a small-scale example of thermal expansion. The spoon becomes warm to the touch because the heat from the tea causes the metal molecules to vibrate faster, transferring that energy to your hand. This same principle applies to larger structures like buildings and bridges, where thermal expansion can have significant effect. This expansion and contraction of metals due to temperature changes are crucial considerations in engineering and construction. Engineers must account for these changes to ensure the safety and longevity of structures. For instance, the Eiffel Tower can grow up to 6 inches taller during the summer due to thermal expansion. Understanding and planning for these changes is essential in preventing structural failures and maintaining the integrity of buildings and infrastructure. Section 4. The Eiffel Tower's summer stretch. The Eiffel Tower, standing tall at over 300 meters, is made of iron, a metal that expands significantly in heat. This iconic structure, designed by Gustave Eiffel, is not just a marvel of engineering, but also a testament to the intricate relationship between materials and their environment. Iron, the primary material used in the construction of the Eiffel Tower, has a unique property. It expands when heated. This phenomenon is particularly evident during the hot summer months in Paris. During a hot Parisian summer, the tower can grow by as much as 15 centimeters. This expansion is due to the increase in temperature, which causes the iron to expand. The change might seem small, but for a structure of this magnitude, it is quite significant. This expansion is most noticeable in the tower's height, as the metal beams expand upwards. The tower's height can increase by several centimeters, making it a dynamic structure that changes with the seasons. To accommodate this movement, the Eiffel Tower was designed with expansion joints that allow its structure to expand and contract without causing any damage. These joints are crucial in maintaining the integrity of the tower, ensuring that it remains safe and stable despite the changes in temperature. The design of the Eiffel Tower is a perfect example of how engineering can adapt to the natural properties of materials, creating structures that are both beautiful and functional. Section 5, Beyond the Tower, Thermal Expansion in Our World. Thermal expansion isn't just a scientific curiosity, it has practical implications in our everyday lives. From bridges to railroad tracks, engineers must account for thermal expansion when designing structures. Expansion joints, like those in the Eiffel Tower, are built into bridges and roads to allow for expansion and contraction, preventing buckling and damage. Similarly, railroad tracks have gaps between segments to accommodate expansion during hot weather, preventing them from warping. Section 6. The Eiffel Tower, a symbol of innovation. The Eiffel Tower, completed in 1889, was a marvel of engineering for its time. Designed by Gustave Eiffel, it was initially met with skepticism and criticism from many Parisians and artists who thought it was an eyesore. However, over time, it has become one of the most iconic structures in the world. symbolizing not just Paris but the spirit of innovation and progress. Its innovative design, including its consideration of thermal expansion, made it a symbol of human ingenuity. The iron lattice structure was revolutionary, allowing the tower to reach unprecedented heights while remaining structurally sound. This design also meant that the tower could expand and contract with the changing temperatures, a feature that was crucial for its longevity. The tower's ability to withstand the test of time, including the constant expansion and contraction caused by temperature changes, is a testament to the skill and foresight of its engineers. Over the years, it has faced numerous challenges, from weathering the elements to surviving 2 world wars. Yet it has stood tall, a beacon of resilience and adaptability. Today it stands as a reminder of the importance of scientific understanding in architecture and engineering. The Eiffel Tower continues to inspire engineers, architects, and artists around the world. It attracts millions of visitors each year who come to marvel at its beauty and the genius behind its construction. As we look to the future, the Eiffel Tower remains a powerful symbol of what human creativity and determination can achieve. Section 7. The Tower's Secret Revealed. The Eiffel Tower's summer growth spurt, a result of thermal expansion, is a fascinating example of science in action. It highlights how even seemingly unchanging structures are influenced by the world around them. The next time you see a picture of the Eiffel Tower, remember its secret is not just a static monument but a dynamic structure that breathes with the changing seasons.